Hello all and welcome to this tutorial. In our tutorial today, we will discuss about prompt engineering. Prerequisites for this tutorial is knowledge of artificial intelligence, machine learning, Gen AI or generative AI, and conversational AI. Hence, if you do not know what these technologies are all about, please refer to these videos that I had created some time back. URL to these videos are mentioned right here at the bottom. I will also have them mentioned in the description of this video. These are some reference URLs. I would certainly recommend that you visit these URLs as they have additional information on this particular topic. I will have these reference URLs also mentioned in the description of this video. So before we jump into prompt engineering, let us understand what is a prompt. A prompt is a natural language text that requests the generative AI model to perform a specific task. So let's say if you are interacting with some kind of a Gen AI model, could be a GPT, could be Chat GPT, some form of a model. And in order for you to interact with that model, you will have to tell that, hey, do this, or what is the date today, right? Why is the sky blue? Or, you know, when is Christmas? You could ask any specific question that you would like, or what is the capital of US? So you will have to type out something in English or maybe some other language, but some human known language, a language in which humans converse, or that is also called as a natural language. And then you will have to give that as a request to the generative model so that it can take your request and then perform a specific task. That is essentially work on that request, process that request, understand that request, and generate a response for you or do something for you. So that specific request or whatever you're typing out, that essentially is a prompt. So, in very simple words, the user input or the user request in English or whatever language, a human known language, that is given to Gen AI or the Gen AI or the machine learning model, which basically instructs the model to perform a specific task, is known as prompt. So, this is the simplest definition that you can give anyone. By the way, this could be one of the questions that could be asked to you in an interview. So ensure that you have a decent answer as to what a prompt is all about. Now let us discuss what is prompt engineering. Now, prompt engineering is the process where you guide Gen AI solutions to generate desired outputs. So the user came and told you, okay, why is the sky blue? Or write me an essay on love, or write me a romantic poem, or write me you know uh, a small paragraph, or write a small paragraph for me on uh, the different states of US. It could be anything that they want to ask. Now the user is only given you a specific prompt. That prompt may not be enough for the Gen AI model or your machine learning model to develop a desired, relevant, accurate, high quality output. And that's where prompt engineering comes in, wherein you take this prompt and you engineer the prompt correctly so that the AI model can generate the desired output. The desired output is as per the user's request or the user's prompt. So hopefully that is clear. Now, even though AI attempts to mimic humans, especially Gen AI, it requires detailed instructions to generate this desired output. And remember, between prompting, generating basically processing a prompt, understanding a prompt, and then generating, the desired output. Generation of the desired high quality relevant output is the most important step, because even if your model can process the prompt, understand the prompt, but it fails to generate a high quality, relevant, accurate, desired output for the user will stop using your particular model. So, generation of a good, high quality, relevant, desired, accurate output is the key step in any Gen AI system, or basically in any AI or ML system. And in order for these AI ML models to do that, it requires detailed instructions. And that is what is prompt engineering. In prompt engineering, you can choose appropriate formats, phrases, words, symbols, or anything that can guide AI to interact with your users more meaningfully. Remember, the user interaction is taking or processing the prompt, understanding the prompt, and then finally generating a response or an output for the desired user. And generation of that output, again, I cannot stress enough, that is the most critical part, because remember, the next question or the next prompt of the user is going to be dependent upon the output that is generated. If it's garbage, that person is just going to close the browser and leave. If it is relevant, then the conversation may continue further ahead. If it is satisfactory, high quality, to the point, accurate, the user might decide to say thank you and leave. Okay, or might even provide feedback. So this is what is prompt engineering. So essentially, prompt engineers guide the AI models to do the right job or do a good job to ensure that whatever output that has been generated is high quality, relevant, accurate, and as per what the user's request or the prompt is. Now, these are the different prompt engineering techniques. And before I dive deeper into this, I just want to put my 2 cents over there. Today, when I'm recording this video, it is August 2024. Prompt engineering is probably one of the most highest paid jobs in the market. And it will probably stay for a few years. So if you are looking to, let's say, change your job or change your profession or learn something new or anything of that sort, then try going in the direction of prompt engineering. Of course, all of these engineering techniques require a good science background, a good knowledge of statistics and math, and a good knowledge of Python. But don't let that stop you, because I've known a lot of people who don't even have a science background have learned these engineering techniques and have mastered prompt engineering. So I would certainly recommend that you learn Python and learn some of these techniques. It will take time. These techniques are not easy. What I am about to discuss is literally not even the tip of iceberg, is the tiniest tip of the iceberg. I can put it like that. It's basically just one liners, as you can see over here. But if you can master some of these techniques and learn how prompt engineering works, then this can be a very lucrative field. It is a very lucrative field, and it has got a bright future as well. It has been around for a while, so it's not like it's a job of the future, but it is going to remain lucrative for a few years, a few coming years, possibly even a decade or so. So learn it. Okay. Now let's deep dive into some of these prompt engineering techniques. By the way, each of these techniques can be a dedicated video on itself. Now, I don't have that kind of time, knowledge, or even that depth of knowledge myself to kind of create a video on each one of these techniques. but you are more than welcome to go ahead and explore these techniques on your own. Apologies, this slide is very busy, but unfortunately, there was no easy way for me to get all of this information together. If required, pause the video, read through the slide, read through the technique, read through the example, and proceed further ahead. I'm going to discuss all of these techniques now. So, prompt engineering is a dynamic, evolving field that requires linguistic and creative skills to fine tune prompts to obtain a desired response. I think by now you've probably understood this very well. And below are some of the example techniques that prompt engineers use to improve their AI model using NLP tasks. If you do not know what NLP is about, NLP basically stands for Natural Language Processing. Please refer to my video on conversational AI. Over there, I have discussed NLP, NLU, and NLG, what I call as NLPUG, in detail. Okay, so go ahead and look at these videos that I had mentioned earlier in prerequisites. Most of the times, whether it's an interview or a conversation, people will only refer to these acronyms. So you have to be very well versed with these acronyms. Okay, so the first technique is a chain of thought prompting. In this technique, typically prompt engineers break down a complex question into smaller logical parts that mimic a human train of thought. So let us take an example. What is the capital of France? This is a prompt. So what the prompt engineers are going to do and how they're going to program and train their model is that the model will now perform several rollouts. Rollouts is multiple responses leading to answers like Paris. Now you will see that each and every answer over here is same but is still different. The capital of France is Paris, or the Paris is the capital of France. Now all these rollouts lead to the same conclusion, Paris, and hence the final selected answer is Paris. Now what happened over here is that for the same question, the model was trained to perform or think in different ways. That is different rollouts. But now each way is now each response is is going to bring a specific answer. Paris, the capital of France is Paris, or Paris is the capital of France. You see that the intent is the same, but the way the answer is formed is different. Right? So there are different rollouts, different answers, and then a commonality is found, and then a final answer is selected. That, hey, in all of these three different rollouts, or in all of these different answers, the commonality is Paris, and hence that is my final answer. So, this is one way of how you can certainly program your AI model. Now, just like you have the chain of thought, right, you have a tree of thought prompting. Now, in this particular technique, the model generates one or more possible next steps and then elaborates on each next step using a tree search method. So, let's take an example again. What are the effects of climate change? The model might first generate the possible next steps like list the environmental effects, list the social effects, and then it will elaborate on each of these subsequent steps. So in this case, you have two branches. Now, potentially, depending upon what the question is, there could be multiple branches. And then basically say, okay, if somebody has asked me this question or somebody asks you a question, what are the effects of climate change? First, you list down the environmental effects. So maybe first you list down what is climate change. You explain that, right? Why climate change is important. List the environmental effects of that. You list the social effects of that. right? If there are any other effects beyond social, environmental, maybe there are some health effects, enlist that. So, and then go back to these individual branches and then continue to elaborate on each one of these branches. Okay. So, it's basically like a tree of thought. And what it does is that each tree, each branch within the tree that it has created, or it may create multiple trees or multiple branches within the tree. It will go back, search the tree, and then go to each of the branches and start elaborating further. This is tree of thought prompting. After that, you have meiotic prompting. And this is similar to tree of thought prompting, in which the model is prompted to answer a question with an explanation. The model is then prompted to explain the parts of that explanation. But in meiotic prompting, what happens is any inconsistent explanation trees or branches are pruned and discarded. So let's say if the question that is asked is, why is the sky blue? Then in that case, the model might write the first answer, the sky appears to be blue to the human eye because the short waves of the blue light are scattered in all directions by the gases and particles in the Earth's atmosphere. And then it will go back to this on certain parts of this explanation, such as why is blue light scattered more than the other colors? What's the Earth atmosphere composed of? And then keep on elaborating and building on its response. The next one that we have is complexity based prompting. Now, in this particular technique, several chain of thoughts are chain of thought rollouts, not chain of thoughts, but chain of thought rollouts, sorry, are performed, and it chooses the rollouts with the longest chain of thought and then chooses the most commonly reached conclusion. So if a question is asked is, let's say, a complex math problem, then the model will perform several rollouts. That is, it will try and resolve the question in multiple ways, right? And each rollout involving multiple steps of calculation. What it would consider, remember, is the longest chain. So it would consider the rollout with the longest chain of thought, which for this example would be with the most steps of calculation. Because then it understands that, hey, this is the most complex one for me. Because the longest one, it has most number of calculations. Then it will consider all the rollouts that reach to a common conclusion with other rollouts, and then finally select its common or a final answer. So this can get a little complex. So what it may take a while to even understand that. So in very simple words, let's say if your math problem, you have multiple rollouts, each involving multiple steps or calculations. It will select a rollout which has the most number of steps in the calculation, considering that that's the most complex one. It will also consider, so once it's got the longest one, now it is going to consider the rollout which has the common conclusion over here. Because remember, it's trying to solve a math problem. And then it will consider the different rollouts which have the common conclusion and then select its final answer, considering the longest one and the different ones which have the common response, and then come up with its final answer. So that's why I said it can become a little complex, because it is not only looking at the complexity, but it is also looking at commonality. The next one that we have is a generated knowledge prompting. In this particular technique, the model first generates relevant facts needed to complete the prompt. And then it proceeds to complete the prompt further. So it will first generate all the facts, and then it will take each one of those facts and elaborate on it to basically complete it. So let's say if the user prompts the model, say, hey, write an essay on effects of Deforestation. Then the model might first generate facts like deforestation contributes to climate change, it leads to loss of biodiversity, and then it will elaborate on each one of the points in the essay. The next one that we have is the least to most prompting. In this particular engineering technique, the model is prompted first to list the sub-problems of a problem and then solve them in a sequence. Now, it also ensures that the later sub-problems can be solved with the help of the answers of the previous sub-problems. Now, again, typically this technique is used to solve math problems and hence it can get very complex. So let's say the user prompts a model with a math problem like solve for x in the equation 2x plus 3 is equal to 11. This is the problem. Then the model will first list the sub-problems, such as subtract 3 from both sides, divide by 2, right? And then solve them in a sequential manner. Remember that some of the latter or the later sub-problems that it feels that it is going to encounter, it will solve in such a way that those sub-problems can be solved with the answers of the previous sub-problems. Because when you're trying to solve an equation, you have to have the steps, and the steps should be all connected. And if you're going to encounter a problem later on, then some of the steps earlier should address that problem so that the latter problems can be solved easily. Okay. So again, this can get very, very complex and very, very challenging. I mean, it's amazing that some of the very complex equations are solved by these ML models with absolutely, you know, uh, no challenge or with an absolute ease. So do test it out with, if you have any of your Gen AI or machine learning models and see if it can solve your math equation for you. The last two engineering techniques are self-refined prompting and directional stimulus prompting. Now, in self-refined prompting, a model is prompted to solve a problem. Now, in order to solve the problem, it will solve the problem first, then it will critique its own solution, and then again resolve the problem considering the problem, solution, and critique. So, what it does is it takes a problem, it finds a solution, then it criticizes its own solution. When we say criticize its own solution, that means it's refining its own solution. And then it keeps on doing this in a repeated manner over here until it reaches a predetermined reason to stop or until it reaches a solution that is satisfactory. So let's take an example again. Write a short essay on literature. Now, again, model is going to, draft an essay. It will critique itself for, let's say, lack of examples. Then it'll rewrite the essay to include some specific examples. Again, it'll critique itself, let's say, maybe for being too elaborative or having too long sentences or something. Again, it'll make itself, work on it. It'll critique itself. It'll make its language more crisper. And then it will continue to do that until it finds the essay to be satisfactory or it meets a stop criterion, right? So once either of these is met, then it's stop. So basically, this is one of the ways it's kind of, again, mimicking humans, wherein we work on something, then we critique it, we refine it, we rework on it. As humans, we do that till the time we ourselves are satisfied by that. And the next one over here is directional stimulus prompting. Now, in this prompt engineering technique, once a prompt is given, the prompt engineer tends to include a hint or a cue, such as certain desired words to guide the language model towards a desired output. Now, let's take an example again. Let's say the user prompts write a poem about love. And now the prompt engineer is going to take that prompt and maybe craft the prompt to include certain other words, right? Like heart, passion, kisses, I don't know, eternal love, magical, mystical, op, awesome, I don't know, whatever romantic words that, the prompt engineer feels that should be included to ensure that the output that is generated by the model is as per the user's desire and is accurate, is of a high quality, and is relevant. Because if the output is not as per what the user wants, then the user will stop using that particular model. Now, these are some prompt engineering techniques that I have literally touched on. Do go ahead and basically search some of these techniques, understand, learn some of these techniques. You can combine some of these techniques as well. That's totally up to you as a prompt engineer, but hopefully this gave you a good foundation. Finally, we are going to discuss the use cases for prompt engineering and how prompt engineering techniques are used by AI systems to improve user experience with learning language models or large language models. First is for subject matter expertise. Let's say a doctor or a physician could use a good prompt engineered language model to generate different diagnosis for a complex case. Again, there are in this application, the engineers prompts or guides the AI model to first list all the possible diseases associated with the entire symptoms, sorry, and then the prompt engineer has to ensure that the model is guided to narrow down the list based on some additional patient information. So yes, all of this is possible. The next one is critical thinking. In this, typically, it's a decision making scenario wherein you could prompt a model to list all the possible options, evaluate an option, and then recommend the best solution. And finally, we have creativity. Let's say a writer could use a very well prompt engineered model to generate ideas for a story, to list possible characters, setting, plots, even develop a story with all these elements. Or a graphic designer could prompt the model to list a set of color palettes, or even list a set of color palettes, or create a design using a palette for a certain emotion. When we say for a certain emotion, could be a specific event. For example, hey, create a design using a specific palette for someone's wedding or someone's birthday party. Or it could be a negative or a sad emotion like, hey, someone's death anniversary. So all of this is possible. So I hope that this video was helpful. This is it from me today. Do post your comments and I will see you shortly in some other video. Till then, take care. Bye bye.